Hi everybody, this will be a little review of some of the conjectures that we have learned so far in this unit, and we'll go over, to do that, we'll go over problems 1 through 6 from page 10 in your note packet. So again, page 10 in your note packet, you just had 1 through 6 though. Okay, so number 1, they are looking for x, which based on where that is placed, that's this arc measure. The measure of an arc is the same as the measure of its central angle. So this one is just 165 degrees, nothing more to do with that. Number 2, we learned from our chord properties that if you have congruent chords, follow the tick marks here, then you also have congruent arcs. So this arc over here is also 128 degrees. We know that all of the arcs in a circle should add to 360 degrees. So just take away what you have so far, 128, 20, and another 128. That leaves you with 84 degrees for Z. Just keep in mind if they were to also ask for this angle, it would also be 84 degrees. Number 3, if you have congruent chords, like we do here, you also get, what they use this phrase, they determine central angles that are congruent. So these angles are congruent. W is also 70 degrees. Number 4, AB is equal to CD. So we know that we have congruent chords. PO is 8. We want OQ, but we learned that if you have chords that are congruent, they are equidistant from the center of the circle. So that's what those 8 centimeter measures are showing us, how far they are from the center. So OQ is 8 centimeters. Let me also just mention, in case this comes up in a later problem, when you have the perpendicular from the center to a chord, it's also the bisector of the chord. So we didn't need that in this problem in particular, but that's definitely something you could see as well. Okay, so you'll kind of, these 3 concepts sort of come as a package deal. You've got the perpendicular, you've got the bisector, and you have that these distances are the same. Okay, moving on. Number 5, AB is a diameter. Find the measure of arc AC. Let's just start there right now. 68 degrees, same as its central angle. And find the measure of angle B. Now this one we haven't quite figured out a quick way to do this yet, so let's sort of walk through what else we do know. If this is a diameter, it's breaking the circle in half. So I've got a full 180 from A all the way around to B. So if I take away the 68 that's already there, that leaves 112 degrees for this arc. Now you could also, maybe this is a little easier for you, you could also just throw 112 as that central angle because that's a linear pair. So you can either compare that to arc CB or you can just find it from a central angle. Now something that tried to get you in the habit of doing, hopefully you are at this point, is marking radii congruent. Now we've got 3 of them here, but particularly I care about the 2 that are in this triangle because this now is an isosceles triangle, which means that these 2 angles have to be the same. So we've got 112, subtract that from 180, that leaves you with 68 degrees, and then we can cut that in half. These are both 34 degrees. Okay, now just a little preview of what's to come. I don't know if you notice something here. Let me maybe highlight. B, so this angle CBA is, remember, what we call an inscribed angle. And here's its intercepted arc. So I just want you to kind of take a look at those numbers. We've got 34 and 68. Maybe notice a relationship between the 2. That's something that we'll learn very soon in another lesson. Okay, and then last one here, number 6. Okay, we have, this is a kite. You can see the markings are actually already there. Find W, X, and Y. Those are all arc measures. So I'm going to start with W because I can see its central angle here. 15, because its central angle is 115. X is also 115 because if you have congruent chords, then you have congruent arcs. And Y takes a little more effort. But I know a full circle, all of those arcs should add to 360 degrees. So I'm going to take away 115 and 115. What we're left with then, just divide by 2. So these, we're left with 130. These both happen to be then half of that, or 65 degrees. You could also very easily, or just as easily, work inside the kite here at all of these central angles and fill these in, right? So if you've got congruent chords, you also have congruent central angles, and then sort of do the same thing, because we know this is a full 360. You could get 65 this way, and then just bump out to the arc from there. So it's up to you if you want to work full 360 kind of around the outside of the circle with the arcs, or full 360 inside, because those angles themselves also make up a complete circle. Okay, make sure you can take your time, go back and listen to any parts of this video that you need to, and then you have, check the assignment for today. You have some work to do from the Practice Your Skills packet. Please don't forget to submit a picture of that work when you're done. All right, everybody, enjoy the rest of your day.